Hey everyone, we're on the second part of our circles unit and we are learning how to do arc length today. So when we're finding arc length, we're just finding a portion of the circumference. So a portion of the perimeter of a circle. And the arc length formula is arc length equals the degree measure of the arc, x, times the circumference, divided by 360 degrees. Okay, and we'll just go ahead and start applying it because I don't want this video to be too long. The directions are to find the length of each bolded arc to the nearest hundredth. So arc length equals the degree measure of the arc, which is 107, times the circumference. Okay, and we know that the circumference is pi times diameter, so I'll just write that on the side here. Pi times diameter, right? So I'm going to put pi times, and my diameter is twice the radius. So if my radius is 6, the diameter is 12. Okay, so we have x times c divided by 360. So I'll plug that into the calculator. 107, oops, oh, that didn't work either. 107 times pi times 12, all divided by 360. So 11.205, and we're rounding to the hundredths place, so that's going to be 11.21. Arc length is 11.21, and my units are meters. Okay, so on number 3, it looks like they gave me the degree measure for the unbolded portion of the circumference, right? That's not what I need. I need this degree measure. So to find that, I'm going to take 360 and subtract the 142. To find the degree measure that I need, 218 degrees. So arc length is 218 times circumference, pi times diameter. Now my diameter is 8, all divided by 360. So 218 times pi times 8 divided by 360. 218 times pi times 8 divided by 360. It's 15.219, so that rounds to 15.22 centimeters. Okay. I'll leave you guys number 5 and do number 6. So number 6, we have the radius NR is 8. Find the length of the major arc NMP. Okay, so major arc is going to be from N through M to P. So I just bolded that in pink here. Okay, and it looks like they gave me this central angle, and MRQ is 162. Okay, but I need the central angle from N through M to P. Okay, so how am I going to find that? Let's see. All right, well, let's see. We know that MRQ and NRP are vertical. That makes NRP 162. So if I'm trying to find everything else besides 162, I would subtract it from 360, right? So if I do 360 minus 162, then I get 198. Okay, so this degree measure is 198, and that's what we're going to use for our arc length formula because we're trying to find the major arc. Okay. 198 times circumference. Our radius is 8, so diameter is 16 divided by 360. Okay, I plug it in. 198 times pi times 16 divided by 360. 27.646, we'll round as 27.65 and feet. All right. Let's see what we got for the other side of these notes. Whoa, too far. Sorry. Okay. How about number 8? This looks challenging. So we have JH is 21 inches. That's the diameter. Okay, so that's good. We know the diameter is 21. Find the length of the major arc, KJG. From K through J and then all the way to G. All right, so it looks like we have to find these angles, vertical angles, and then add it to 59 and 85. All right, so let's go ahead and figure out this KLG, which we could do because KLG and JLI are both 85 because they're vertical. So I'll do 85 minus 59, that's something they gave us, to find 26. Okay, so KLG is 26 degrees. All right, and that's the only piece that we don't need, right? This KLG. So my degree measure of my arc from K all the way around to G, right? Because I'm finding the major arc, KJG, is going to be 360 minus 26. So 360 minus 26 is 334. That's the degree measure of the arc. 334. Okay. So arc length equals 334 degrees times pi times diameter divided by 360. Plug it into our calculator. Now let me move it because I can't see. 334 times pi times 21 divided by 360. 61.21 inches. Okay. All right, let's go ahead and try number 10. If WS is 4.5, so my radius is 4.5, my diameter is 9, right? We'll double it. Find the length of arc TS. All right. This one's not too hard. So hopefully you're able to see PWQ, that angle, and TWR are vertical. Okay, so we're going to just subtract this 31 degrees from 128 to find the angle that we need. So I'll do 128 minus 31 to get TWS is 97. So this degree measure is 97. Okay, that's what I need. So I'll do arc length equals degree measure times circumference, so pi times diameter, pi times 9 divided by 360. 97 times pi times, 9 divided by 360. 7.618, we'll round to 7.62. And dimensions is millimeters. Okay, and then we have 11 and 12, which are our application problems. So I'll try number 12. It says, a car enters a roundabout from Mason Avenue, travels 280 feet, then turned onto Perry Street. If the roundabout has a diameter of 150 feet, find the angle of rotation. Okay, well, this one's tricky. So they give us the arc length, right? If it travels around a circle, okay, and it's not the entire circle, that's the arc length. So I'm going to put that equals L. Turn onto Perry Street. A roundabout has a diameter of, so they give us D equals 150. Find the angle of rotation. So we're trying to find X to the nearest degree. Okay, so they gave us arc length equals 280. Okay, and we'll set it up for the formula, right? That's X times circumference. And the circumference is pi times diameter. Pi times 150 divided by 360. Okay, and we're going to work backwards here a little bit, but it's not too hard. I will just go ahead and multiply by 360 to get rid of my denominator. So I have 280 times 360, which is 100,800. Equals X times my circumference, which is pi times 150. Okay, and if we're trying to get X by itself, we'll divide both sides of the equation by pi times 150. Right, those cancel. Pi times 150. Okay, and that gives me X by itself. So let's go ahead and plug it into the calculator. 100,800 divided by, I'll put my pi times 150 in parentheses. 213.9. Okay, and they wanted it in the nearest degree. So I'll say that X equals 214 degrees, right? 213.9 would round to 214. Sorry. Okay, so that's how far the angle of rotation is that this car traveled. Okay, not too long. Go ahead and do all the ones I skipped. Thanks. Bye.